7.6 Separation of variables. If you recall implicit differentiation from 3.2, this here, 7.6, is like backwards, doing this backwards. So, let's do this first example here. dy dx is equal to x squared. You want all the y's and dy's on one side, and all the x squares and dx's on the other side. So, you can multiply both sides by y. So you have a y dy, but also at the same time multiply the dx over. So it's x squared dx. Once you have this, now you can take the integral of both sides. When you take the integral of both sides, you get a y squared over 2 using the reverse power rule equals x cubed over 3 plus c. And you only need to do a plus c on one side. Because if you had c's on both sides, you subtract it over, it'd still be some constant on one side. So we just write it on one side here. Continue from here. So you can multiply both sides by 2. So y squared is equal to 2/3 x cubed plus, so we could write 2 times c, but it's still a constant. It doesn't really matter. If you multiply the 2 by c again, it's still a constant c. Now you can square root both sides, because if you square root a y squared, that gets you a y, and then you do a plus minus square root of 2/3 x cubed plus c. This here is your general solution. Question 2. So let's separate the variables here. Divide y squared on both sides, so it's, and you move the dx over, so it's 1 over y squared dy is equal to sine x dx. Take the integral of both sides. You have y to the -1 over -1 equals negative cosine x plus c. So this is the same as -1 over y equals negative cosine x plus c. Let's multiply both sides by -1. So 1 over y is equal to cosine x. You can do plus or minus c, but just stick with a plus c because it's still a constant. It doesn't matter. You don't have to change the c, just everything else. Now, you know, y is just equal to 1 over cosine x plus c. You just flip this around. Again, this is the same as also if you multiply both sides by y and then divided both sides by cosine x plus c. This is what you get for y. Let's do these examples here now. Separate the variables, divide both sides by y, and then multiply both sides by dx. So we have a 1 over y dy is equal to x dx. Now you take the integral of both sides. We have an ln of y, absolute value of y, equals x squared over 2 plus c. So, if you remember, this could be new to some of you guys. If you have an ln of y and you want to make this a y, you take e and raise it to the exponents right there. Because e to the ln y, that's just y. And then on the right here, you just leave it as is. Well, it's e to the x squared over 2. And you can think about that as multiplying, if it's a plus c, you can think about it as multiplying e to the c. And then e to the c, that's just a constant still, so you can rewrite this as y equals ce to the x squared over 2. I'm going quick with these, so if you're confused with how to do some of these, please pause the video and ask your teacher right now. Question 4 right here. You notice how you first have to factor this because the xy is combined and you're adding something. So you can say dy dx is equal to factor out the 2x, parentheses y plus 2. Now the variables are separated, you can do the separation of variables. So you have a 1 over y plus 2 dy equals 2x dx. On the left, that's just the ln of absolute value of y plus 2 equals integral of, or I forgot to write the integral sign here. Oops, not there. To write that right here. Integral of 2x is just x squared plus c. Now, again, take e to these powers here. So you're left with a y plus 2 on the left is equal to e to the x squared plus c. So where e to the x squared plus c is ce to the x squared, and you subtract the 2 over at the end. So y is equal to ce to the x squared minus 2. Any questions, let your teacher know. Otherwise, you can start the practice.